Let's review how to solve a right triangle. And a reminder, when you are asked to solve a right triangle, this means to find all the missing sides and all the missing angles. So in this given triangle, GEM, we are given that side G is 7, side E is 4, this side is missing. I need to find the hypotenuse. And I also need to find angle G and angle E. Let's begin by finding side M. I have a right triangle, and so I'm thinking I can use the Pythagorean theorem to solve for that missing side. That looks okay. The Pythagorean theorem says leg 1 squared plus leg 2 squared is equal to the hypotenuse squared. Now I'm the type of problem solver who likes to label the triangle. Therefore, I will label this as leg 1. Here's leg 2, and here's the hypotenuse. Now just a reminder, it doesn't matter if you'd labeled this one leg 2 and this one leg 1. That's interchangeable. What is not interchangeable is the hypotenuse. The hypotenuse is always across from the 90-degree angle. Okay, so let's use our numbers, our information, to solve for M. So leg 1 is 7, and I'm going to square it. Leg 2 is 4. Square that, and my hypotenuse is M. I'm going to solve it. 49 and 16 is M squared. This is 65, which means that M is root 65. Now I'm going to be a good egg. I was asked to solve the right triangle, so I'm going to box off my answer. Next, let's solve for the missing angles. I need to find angle G and angle E. And since I have a right triangle, I know I'm going to be using sine, cosine, or tangent. So I'm going to write my handy way of remembering these. So SOHCAHTOA. Remember to spell it correctly if you're going to use this. Now I can make a choice. I can either solve for angle E or angle G first, and I'm going to solve for angle E. Now, relative to angle E, I'm going to label all of these sides of the triangle. So relative to angle E, this side right here is adjacent to angle E. It is next to. And then relative to angle E again, this side over here is opposite from angle E. And finally, I have this, the hypotenuse, which is always the hypotenuse. I will just label this the hypotenuse. Now I look at what I have, and you may actually use any of these 3 trig ratios because I have all of the sides of the triangle. So if I want to solve for angle E, let's use cosine. So I have adjacent and hypotenuse. And let's put it all together. So cosine of angle E is adjacent over hypotenuse. Adjacent over hypotenuse. So I'm going to write 7 over the square root of 65. Now, if you have the cosine ratio, which is 7 over square root of 65, and you are trying to find the angle, what I want to use is inverse cosine. So I'm going to set that up. Inverse cosine says if I have the ratio, I can get the angle. So let's go ahead and set this up. So I have cosine, the inverse cosine of 7 over the square root of 65 is equal to angle E. Now take a moment to input that into your calculator and let's find out what you get. So when I put that in my calculator, I get that angle E, I'm going to say is approximately, because I'm going to round it off, 29.7 degrees. And again, I was asked to solve this right triangle, so I'm going to be a good egg and box off my answer. finally, there are a few ways I could use to solve for angle G. I could use another inverse trig ratio, and I could use maybe inverse cosine again. I could use inverse sine, even inverse tangent I have right here. Or I notice that I have one angle in a triangle. I have the 90-degree angle, which means I could use the triangle sum. So to find angle G, I can say 90 plus 29.7, it's supposed to be a plus angle G would equal 180. And the answer you end up getting for angle G, is about 60.3 degrees. And now we've solved the triangle. To summarize, if you are asked to solve a right triangle, you are being asked to find all the missing sides and all the missing angles. You may need some or all of the following tools. You may need your trig ratios, so you may need sine, cosine, or tangent. You might need to use the inverse trig ratios. If you're trying to find the angle and you have the ratios. And finally, you might need to use the Pythagorean theorem. Don't forget our good friend here.